Hello, let's spend some time and talk about more design issues associated with building data marts and putting them into a data warehouse or just in your own data store. And again, if you're looking to do more than just generate one report on one day with the data set that you're bringing in, you will want to design something that will withstand the test of time, allow you to expand it, and do more reporting. And that brings us to what to actually put in your extended data marts or data warehouse. And what I have found works is we're going to talk just briefly about discrete facts. What that means is don't overload your fact tables. Don't try to bring in everything into one fact table. Build fact tables that meet a specific need, and then you have more chances to be nimble and to expand out by building additional fact tables. It's not expensive. It doesn't cost a lot of storage. It's not a lot of work to create these much more discrete fact tables rather than figuring out how to maintain a very large fact table with lots of metrics in it. And then that sort of leads us into when you do this, how can you get this data together? Well, this is where you begin to bring in common dimensions, which is really a dimension shared across multiple sources of data, and that begins the process of building your federated data warehouse. Now, federated data warehouse is another one of those terms that is widely misused, misunderstood, and every data architect and data modeler sort of has his own vision of what it would be. So we'll take a look at what I believe to be your federated data warehouse. So here's our problem and where we will look at what we will be doing in the dimension area, and that is that Daisy Hill Puppy Farm has three separate systems. They don't talk to each other, they don't work together, and so therefore reporting across them is not feasible without bringing them into a common data store. We have the registration, the attendance, and the billing system, anything that you would do as far as the training the puppies is concerned, but they want to know is how many people are actually paying their bills that they're being registered, who's attending which ones, uh, and which of the trainers is more successful in getting people registered, attended, and actually getting them to pay. And as you can see, since there are three different systems, you really can't report across this data. And so we want to bring this data together. And most importantly, since they are separate systems, they don't share what would be considered master data. And so therefore we want to be able to build simple common dimensions or federated dimensions that will satisfy our reporting across these three areas without having to go to the trouble of getting all the data that we would need to build and maintain a master data set within the data warehouse. If you're interested in master data warehouse, don't forget to subscribe to my channel, drop some comments, and look back into my videos because we talk about building some master data and what entails within there. But in this case, we don't want to go to that direction. So let's begin looking at how to build this as a more federated solution. So what is a federated data warehouse? Again, it's all in the eye of the beholder. It's what you want it to be. It needs to be sophisticated as you want it to be. But what you want to do is have a single version of truth across all your organizations so that a customer is a customer, or a puppy is a puppy, or a trainer is a trainer, a transaction is a transaction, and it only exists in one place or within one definition. And this is mostly, in my vision, looking at the dimensions that you'd be bringing in from multiple sources. How do you get one source of data within your data warehouse so that everybody knows that you can see the different metrics going across them? And to agree, you want to integrate what you're doing and building those dimensions so that they meet the business needs going across your reporting world. And again, this can be a very large, involved process to build a completely federated data warehouse and to meet all the demands and needs of the business community. In this case, though, we are going to simply build a foundation for that by having a common data model, a common staging area, and we're going to simply start and expand over time. So we're just going to take this set of data and utilize it to head into our federated life. So let's take a look at our source data as we talked about this being three separate feeds of data, and it's very terse data that's coming to us. We don't have time to engage or the ability to engage and send large sets of data from each of these three systems. They're very small systems, very limited development, and so they had this feed they sent us very quickly. The registration system sends us the registration ID, so we know a unique transaction. It gives us the name of the puppy and the owner, the course, and the session timestamp. The course and the session timestamp we know to be unique, so that course that's being taught at a specific time is a unique instance of a class. And there's a fee associated with this when someone is registering. The fees may be different from person to person depending upon who they are and who their puppies are. We have some of the same information coming in, but you notice that we don't actually have any puppy information from the payment because payment doesn't care about puppy. It's a person that is being billed for the course. So you notice that we have common data between the courses. We do have common data within here within the owners, but there's no guarantee that the owner is unique just simply by the first name and the last name. There may be a whole lot of John Smiths out there, and they get charged amount, they get a discount, and hopefully they have a payment. And the attendance sort of fits in the middle of this. Again, we have the ID coming out of the attendance system. We have the puppy's name and the owner's name just because that's what they really see is important when that puppy is there to be trained. We have the course name and session name, and then we have the instructor's ID and their first name and last name. And this is probably the best set of data that we could look at as far as building a nice clean dimension. But you notice that we don't have instructor linking into these over here. And that's sort of where this reporting needs to head into. So let's take a look at what we can turn into dimensions as well as what we can't turn into dimensions. So from this feed, we can bring in a standard dimension that I use all the time, and please check out my video on the date dimension because we obviously have a date sitting out there. This again is not a full date dimension if I was to build one for a real data warehouse, but instead this is just gives you an idea of what is the attributes that you might put into a date dimension. Another dimension that I like to create that I haven't talked about before, but it came into play with this data mart, and that is a time dimension. And you create a time dimension for the same reason that you create a date dimension, and that is that there are other things that you might like to know about that time. So for example, you might want to get the minutes and the AM and PM indicators, etc. out of it, and there are additional attributes should you decide to create them, but this gives us the ability to dimensionalize a time, and then you use it as a dimension in any of our query constructs. Continuing onwards, if you look at our data set, we are not going to bring in a puppy dimension, mainly because all we have is the puppy name, and that does not get us into the ability to dimensionalize this. We might have multiple puppies with the same name, and so therefore any reporting would become confusing. We apply the same rationale to the owner. We have a first name and a last name, but not enough information to make that unique and to do additional reporting. If we wanted to do this, we have to go into getting more information from the source system and then look at creating a master data set with that as well. So what are we left with? Well, what we're left with is a couple of specific training dimensions that we would want to be using. To that point, what we have is the training course dimension. Very simply, what we pull out of this happens to be just the course name. It just gives us that stakeholder as well as additional information. And again, what I would look at doing is opening up this dimension to allow the user community to add additional attributes to it in an ad hoc methodology with a separate feed, spreadsheet, something like that. And then finally, something that does look a little bit better happens to be the instructor dimension. But the thing to keep in mind about this is probably a subset of an employee dimension. It is definitely a subset of a people dimension that would be master data. But again, they're giving us enough information to make this unique. And this is one of the key attributes that they want to utilize in their reporting structure. And then the last thing that we want to talk about is how to deal with your outer joins so that you make your querying easier. And I bring in the concept of the none and unknown dimensions. I first used this feature quite a while ago when we were dealing with web analytics, because within the web analytics world there's a lot of unknowns coming in that you don't want to simply bring into your data warehouse dimensions, as well as there's a lot of empty or missing data depending upon the web application, and so it brings the concept of none. Typically I set the warehouse ID in every dimension that I create to have a 0, which specifies none, so you can deal with that null value becoming a 0, saying that for this fact there is no value for a specific dimension. And then the -1, which is the unknown, because we don't necessarily want to always populate things upwards or to deal with values that might be out of range. We can give them a -1, signifying that they're unknown, and this allows you, when you're doing reporting, to see if the unknowns are growing, then there's some breakdown between the source system and the target system, with the data feed going in between, so that you will need to do further investigations. And what this looks like when we bring up any specific table set, and we'll go into my Access database to do this with, bring it into here, and if we look at, for example, the time dimension, how this sort of falls out directly, so to speak. Hello, time dimension, there we go. So what we've done is created a -1. We give it some negative values for the fields that you want to see in here, and give it an unknown for its description. Just so happens that the 0 or unknown is typically midnight, and this actually fits within the data world, that if you have a date only attribute, then the time happens to be midnight, which is 000, and it's considered AM. And so the 0 attribute in this one sort of fits with missing data, and that's one reason why we come up with that. And you can see that we've actually, within this time dimension, added some nice English version, 1:30 a.m., etc., to show you how we would populate this in a separate workflow. And then finally, if we bring in the training instructor dimension, we've just gone ahead and shown that, yes, we have an instructor ID of John Doe, and we have a none in case we have data that is not yet have an instructor. So for example, if we just simply have a payment and not exactly sure which class of course it was done for, the outer join would return a null. We can turn it into 0, and then our dimension would be rationalized, that null value going to 0, going into the dimension and having the none. In this example as well, we probably would never have an unknown, since we would be feeding and populating the dimensions directly from the source data. But in case we're dealing with something in a master data situation where we would not want to utilize this data to update the master data, we would then give it the unknown, so it could be some further analysis in order to fix it. Now we'll take a look at our fact tables. We'll have 3 fact tables, one coming from each of the feeds. They're very simple feeds, and so our fact tables become simple. And again, being discrete, we don't need to combine all this information into one, but simply populate them one at a time. The first event that we would want to track is the registration. And so for the registration, we have a registration ID, which we can set as the primary key. So if we need to, we can maintain this data. We have the course instructor session date and time, dimensions, rationalized, and then we have the fee amount as our fact metric. Second would be they would attend this class. So then we have our training attendance fact table, which has the attendance ID also as the primary key. And then we keep these same 4 dimensions passing down into it. And since there really is no metric associated with this fact, other than the fact that they didn't attend it, we have the attend indicator, which would be a 1 or a 0. 1 if they attended, 0 if they didn't attend, and therefore we can simply summarize or count these as necessary. And then finally, they will need to pay for this class, and so we have our training payment fact. It has a transaction ID as a primary key, and again, this same 4 training dimensions. Then we also have the transaction date, just in case we want to know when the actual payment was made. And then we have the 3 metrics associated with the charge, the discount, and the payment, so that we can do some analysis between them should it be required. So one of the big questions that people ask is, well, this is great, but how do we get this instructor information from the payment, or this instructor information into the registration, since the instructor only exists at the training point? One way you can do this is by keeping data inside of a working table and then utilize that work table to go ahead and populate this. Or in this case, I actually found this information to be useful, and so I created what's considered a helper fact table, or possibly a factless fact table. It is simply trying to join where the definition of the course meets the instructor, which is for the session. So the course is defined as the session is defined as the course, the date, and the time, and then there's instructor associated with that. So this gives us the information so that anytime we have a course and a session for that course, we can find who the instructor is. This is a factless fact table, just like some of the previous tables that we've talked about, and the fact that there is no metric associated with this. So simply we will put in here a count indicator, which will be a 1 for all the records. So it shows us that we can count this in case we would like to know how many trainers were in a session, which should only be 1, as well as how many sessions this trainer may have taught. And so therefore we can use that account. Some people just simply identify a factless fact table by having no metric in it at all. Again, I just like to put a count in there. So having this, when we come into our payment fact, well, then we can just simply look up the information that's in the helper fact in order to pull in the instructor ID to go along with the course information and session information that is already in that feed. That being said, we have built this. What does it look like when we bring the dimensions in? I try to keep this clean. It looks a bit messier because there's lots of lines. But again, we have our 3 fact tables, our registration, our attendance, and our payment. And then we have our 4 dimensions that are around it: the course, date and time, and then the instructor. So this allows us to do queries. So how does this help us in doing a query? Well, it just simply means that when we begin to join the data, we have all the information to go from a dimension to all the pieces of data without having to go elsewhere. And what that looks like from a Venn diagram standpoint is that we have, for example, our queries that we wanted to work with originally had to do, let's look at what's going on an instructor by instructor basis. So with that instructor, we can reach out to the registrations, the attendance, and the payment, whether they exist or not exist at the point in time that we're doing the query. That lets us do left joins in to get those and know that there is a relationship to where all 3 of these will indeed come together. But we also have the left pieces, etc. It's a fun little diagram to look like. You can look to define what each of these little pieces of the circles are, but it just simply shows us the instructor reaches out to each of these, and there's a relationship between them as well, should we decide to do some further analysis. This makes the querying a bit simple because we have done the none and the unknown parts of this. It means that we will always be able to go to other dimensions should we need to go to other dimensions, and we can also use that information to say what what pieces of data don't have in the structure associated with them, and see where that goes from there. So overall, that gives us what we need. This allows us to go ahead and do our querying, creates our discrete fact tables as well as our federated dimensions. Summing it all up, obviously all the picture we have, this ends what we're talking about. I hope this helps you understand how you can direct and how you can pursue putting your data together from different sources. As always, thank you for listening. If you like this, please drop me a comment to let me know that it was useful to you. Subscribe so you can see my future videos, as well as give me comments about what else you would like to see in some of these design sessions. Have a great day.